Working more examples. Let's take a look at this one. 4x minus 12 is equal to the square root of 3x plus 2. We got to get these radicals out of here. Move them out. What we're going to want to do is square both sides. So I'm just going to rewrite this so we don't disturb our original problem. We square both sides. When we square a radical, when we square the square root, I should say, and you should know why, it just falls out. So 4x minus 12 is equal to 3x plus 2. In a previous video, I explained this a bunch of times, why we can square the square root and the square root falls out. Okay? Because remember, if we rewrote it in exponential form, it'd be 4x minus 12 raised to the half. And then you take that half, multiply it by 2, you get 1. All right? Okay, now we have a linear equation. And because 3 is smaller than 4, we'll go ahead and take that over to the left. So we have 4x minus 3x is equal to, we'll go ahead and take that 12 over. Okay, the 2, the 12. So we're subtracting 3x from both sides, and we're adding 12 to both sides. All right, so now we're left with x is equal to 14. X is equal to 14. You should always take this now and go back up into the original and plug it in. All right, it's important because it may not be a solution, a real solution. All right, but I'm pretty sure that one is. I've already checked it out. Okay, let's move on now to something else. Two x is equal to 4, the square root of 4x plus 15. Okay, to get rid of this radical, we need to square it. Okay, so that means that we're going to square both sides. You can't just square one side, you got to square both sides. Square both sides. And now we're left with 4x squared is equal to, radical falls out onto the floor. I don't know where it fell out into, disappeared into the ether. Let's go ahead and take this 4x over to the left of the equals and the 15. So this becomes 4x squared minus 4x. We're subtracting 4x from both sides and subtracting 15 from both sides. Now we have a quadratic equation. And hope that it factors. That's what's important. We got to hope this thing factors nicely. Okay. It could be 4 times 1. I said 4 times 1. In other words, a 4 and then a 1. Okay, or it can be 2 times 2x times 2x. We have this 15 here. It's either going to be 1 and 15 or 3 and 5. And if I put a 3 over there, 4 times 3 is 12. 5. Somehow we add these together, we got to get -4. I don't see it happening. Let's change this. Okay, here, let's just go ahead and erase this. I got a feeling it's 2x, 2x. Let's see, 2 and 5 is 10. 3 is 6. 10 and 6 is, 3 and 5. Right? 2 times 3 is 6. 10. Well, this would be minus 10. Okay. I think that's it. Yep. So now what we'll do is set each one of these equal to 0. So 2x minus 5 equals 0. Solve for x. 2x plus 3. Set that equal to 0. Solve for x. Okay, in this one here, we're going to have x is equal to 5 halves. And x is equal to negative 3 over 2. Negative 3 over 2. So what we'll have to do, or what I said, you got to always go up, and you need to check it in here. Now, the left-hand side, this 2x has to always be a positive number, because remember, we take the square root of a number. It's got to come out to be positive. Okay, we're talking about real numbers here. There's other types of numbers out there, but we're just talking about real numbers. This one here, however, is negative, if you notice. And if we plugged in that negative 3 halves into here, right, that's going to be a negative number. 2 times negative 3 halves is negative 3. And so that can't be a solution. Cannot be a solution. So we know that that's not a solution. Maybe I should put red. Red. Okay, we can't use that number. However, the 5 halves, if we plugged it in here, 5 over 2, 2 goes into 4 2 times. 2 times 5 is 10. 10 plus 15 is, 10 plus 15 is 25. Square root of 25 is 5. Okay, plug 5 halves in over here. You get 5 over 2. The 2's cancel out. You get 5. So that's the solution. All right, so here's your solution. Okay, 5 halves. That's what I'm saying. You got to check. If you don't check, you're going to be in trouble. Big time. Okay, I think we're going to end it here. And I'll see you in the next problem.